So these are some homework problems from section 11.4 that I was asked about. So number 7 is the first one, and we're supposed to find f prime of x. So this is the derivative, and it's the limit as h goes to 0 of the difference quotient. And then we're supposed to evaluate it when x equals 2. That's the meaning of this notation, f prime of 2. And then when x equals 0, and then when x equals -3. So we want a formula for the derivative that then we can plug different x values into. So the first thing we need to find is f of a plus h. So that says everywhere I see an x, replace it with an a plus h. And then f of a is 2 times the square root of a. Then hopefully you've done this a lot of times now, that the next step is to make the difference f of a plus h minus f of a, and then over h. So we're going to have 2 times the square root of a plus h minus 2 times the square root of a over h. Now if I do the limit as h goes to 0 right now, I'll get 0 over 0. So I know that that's not what I should do next, but I need to multiply by the conjugate of the numerator, which says take the same two guys, 2 square root of a plus h and 2 square root of a, and there's a minus between them in the blue, so we put a plus in between them. And then we can't just multiply the numerator by something, we need to multiply by 1. Well, the same thing over itself is always equal to 1, no matter what a and h are. So that's a legal thing to do. I've multiplied by 1. So now I need to look at these 4 terms and FOIL. So I'm going to have outers, 2 times 2 is 4. Square root of a plus h times square root of a plus h is a plus h. Then the whole point of multiplying by the conjugate is that the inners and outers will cancel. They'll be exactly the same but opposite. So then we'll have the lasts, 2 times 2 is 4, square root of a times the square root of a is a. Then in the denominator I'm going to have h, and the 2 times square root of a plus h plus 2 square root of a. Okay, so now I'm going to distribute this 4 in the numerator and get 4a plus 4h minus 4a, and that's all over h times 2 times square root of a plus h plus 2 square root of a. And yay, the 4a and the negative 4a cancel, because we know we always need that to happen at this point. Everything without an h should cancel. So then I'm going to have 4h over h 2 square root of a plus h plus 2 square root of a. So now the h in the bottom and the h in the top are going to cancel because that's equal to a 1. So I'll have 4 over 2 times the square root of a plus h plus 2 square root of a. So this is f prime of a. Oops, not yet, sorry. Almost. This is the difference quotient. And to get from the difference quotient to f prime of a, we need to do the limit as h goes to 0 of the difference quotient. So h is going to go to 0, and that's going to give me 4 over 2 square root of a plus 2 more square root of a. So that's 4 over 4 square root of a. Those 4's are going to cancel and leave a 1. So I'm going to have 1 over the square root of a. So this is the derivative of the function at a. And then we were asked to evaluate it for some particular values. So f prime of 2 says put a 2 in everywhere you see an a. So that's going to be the slope of the tangent line when x is 2. And so that's the answer to the first, find f prime of 2. Then let's find f prime of 0. But if I do that, I'm trying to divide by 0. So I'm going to say that's undefined because I can't divide by 0. So f prime of 0 in this case is undefined. And then f prime of -3, well, now I'm trying to take the square root of -3. So this is also not defined. So if we look at the graph, it can just be really helpful to have the visual of the graph. Here's the graph of 2 times the square root of x. When we're at x equals 2, everything's nice. We can find a number. We get the slope of the tangent line. All is good. But when x equals 0, the function is diving and becoming vertical right at 0, and a vertical line has a slope that's undefined. So if you're asking about the slope of the tangent line, it's going to be undefined when x is 0. And then you can see that there's not even any function happening for negative values of x. So the function is not even defined. Okay, so that's number 7. Next, I'm going to look at number 11. Number 11, or yeah, number 11. Okay, so number 11, my function is 1 over x. So I need to find the derivative, but actually they're given to you in this case. So I'll show you how to find it, but it's actually in example 6, page 601. And what this is saying is they don't expect you to reproduce all that again, but once you've found the derivative once, you can keep reusing it. It's the same derivative for that function. Even if you did it yesterday or you do it tomorrow, you can just use the derivative again once you've found it. So how they find it is, let's do our formula again. F of a plus h is 1 over a plus h. And f of a is 1 over a. So then I find my difference, f of a plus h minus f of a. So 1 over a plus h minus 1 over a. And then I need to get a common denominator. So I'm going to multiply the 1 over a plus h by a over a, and the 1 over a by a plus h over a plus h. So this is just the numerator of the difference quotient that I'm working on. So now we have a denominator of a times a plus h, and a numerator of a minus a plus h. So I'm going to distribute that negative and get a minus h over a times a plus h. And we can see that these a's are going to cancel. So I have minus h over a times a plus h. But now the difference quotient says I need to take f of a plus h minus f of a and divide it by h. Well, that's the same thing as multiplying it by 1 over h. So if that way makes more sense to you, that's fine. So the difference quotient is going to be 1 over h times negative h over a times a plus h. These h's are going to cancel to be a 1. Don't lose your denominator. It's still there. It's a 1, but it's a negative 1 because the negative sign also did not cancel. So here's my difference quotient. Now I want to find f prime of a is going to be the limit as h goes to 0 of -1 over a times a plus h. So the h is going to go to 0, and I'm going to have -1 over a squared. So that's in general. And then this particular problem asks, well, what about at x equals -2? So we're going to say f prime of -2 equals -1 over -2 squared. So that's -1/4. This is the slope of the tangent line to f of x when x equals -2. Okay, so that's my m. Well, then we also need to know a point on the graph. So we need to know f of -2. Go back to the original function, and that's going to be 1 over -2 or -1/2. So the point -2, comma, -1/2 is a point on the graph. And I want to find the equation of the line that goes through that point. So I'm going to use point slope form and say y minus -2 equals the slope of -1/4 times x minus -2. Whoops, this is -1/2. The y goes with the y. So I have y plus 1/2 equals -1/4 x minus 1/2. This minus a negative becomes a plus, and then I distribute the -1/4 to the +2. Okay, so my last step is going to be subtract 1/2 from both sides, and y equals -1/4 x minus 1. This is the equation of the tangent line. So let's go look at the graph. Here's the graph of y equals 1 over x. Here is the point we found that's on the graph, -2, -1/2. So you can use this to check and make sure you really did find a point on the graph of the function. And then we found the equation of the tangent line, and I can see that it is touching at the right spot. And if I zoom in, I can see that, yeah, that line approximates that function quite well. Okay, so the next one I wanted to demonstrate was number 15. So number 15, it's the same exercise with a different function. So I still need to do f of a plus h. So that's going to be a plus h quantity squared plus 3. And then f of a is going to be a squared plus 3. Then I do the difference, f of a plus h minus f of a. So here's my f of a plus h. Make sure you put parentheses around your f of a. And then hopefully you've done a lot of these, so you know a plus h quantity squared is a squared plus 2ah plus h squared. Then we have plus 3, and we distribute the negative and get minus a squared minus 3. So yay, the a squared cancels and the 3's cancel. So what's left is 2ah plus h squared. Okay, so then the next thing we need to do is say, well, the derivative at a is going to be the limit. Oops, wait, we lost one step. We got to divide by h. F of a plus h minus f of a over h is going to be what I have sitting here divided by h. So I'm going to factor out h and cancel, and so now I have 2a plus h. So now I'm going to find f prime of a is the limit as h goes to 0 of 2a plus h. So that's going to be 2a. So then it asks me to find the slope of the tangent line to the graph at the given point. So at x equals 2. So f prime of 2 is going to be 2 times 2 is going to be 4, and that's going to be m, the slope of the tangent line. Okay, so that's the answer to part A, find the slope of the tangent line to the graph at the given point. Then we want to find the equation of the tangent line at that point. So we're going to find f of 2. So that's going to be 2 squared plus 3, or 7. So the point 2, 7 is a point on the graph and on the tangent line. It's the point where they touch. So I'm going to have y minus 7 equals m, the slope of 4, times x minus 2. So y minus 7 equals 4x minus 8. Add 7 to both sides. And the equation of the tangent line at that point is 4x minus 1. So let's go look at the graph. Here's the graph of y equals x squared plus 3. It's a parabola, if you recognize that. Then the point we found on the graph was 2, 7. Then the equation we found was y equals 4x minus 1. Sure enough, looks like it matches up to the actual graph that's read very closely. So I'm feeling really confident about my result. Okay, then the next one was number 17. And really it's the same instruction set. So for this function, I need to do, let's give it a different name just because I don't like that we're using little h in two different ways and that doesn't really make sense. So let's do capital H of a plus h is 7 over a plus little h. Capital H of a is going to be 7 over a. Then I form my difference. Then I need a common denominator. So the 7 over a plus h is going to be multiplied by a over a. 7 over a is going to be multiplied by a plus h over a plus h. So now I'm going to have 7 times a minus 7 times a plus h over a times a plus h. I'm going to distribute that negative 7. And the 7a and the negative 7a will cancel. So I have negative 7h over a times a plus h. Well, this is just the numerator so far. So I still need to do the divide by little h part. And you're welcome to do this all in one step if you're comfortable with that. So remember, dividing by h is the same thing as multiplying by 1 over h. So I have an h in the top and an h in the bottom. That's a 1. So we cancel them. So here's my formula for the difference quotient. Now I'm going to find f prime of a is the limit as h goes to 0 of negative 7 over a times a plus h, and the h is going to go to 0, and I'm going to have negative 7 over a squared. So then I'm being asked about, let's go double check, at x equals 3. So I can find the slope of the tangent line at x equals 3 by plugging in 3 for a and getting negative 7/9. So this is m of the tangent line. Okay, then the next thing we need is f of the 3. So go back to the original function. 7 over 3. So 3 comma 7/3 is your point on your line. And now we can use the point slope form. Y minus 7/3 equals our slope of negative 7/9 times x minus 3. So y minus 7/3 equals negative 7/9 x plus 7/3, and then add 7/3 to both sides and get y equals negative 7/9 x plus 14/3, and that's our equation of our tangent line at the point when x equals 3. So again, let's go look at the graph. I just find this really helpful. Here is the graph of 7 over x. Then we double check, yep, the point we found is indeed a point on the graph, 3 comma 7/3. And then here's my equation of the tangent line. Looks really good, so I'm feeling really confident about my result. Okay, then this last question, it's actually a great question, and I'm thinking about putting it on a test next semester just because it's such a good conceptual question of, are you making sense of this, or are you just following an algorithm without understanding? And I really want you to strive for understanding. So it helps to read the problem probably more than once to get an idea of what's going on, especially if you've not used the self-cleaning oven cycle. So you lock the oven, but the door's not locked yet. But when it heats up to a certain temperature, then the door locks shut and you can't open it again until it turns down to a safe temperature. So all these words say the oven temperature is 100 when the cycle begins. So that's this beginning point here, and it's at 100. It's not at 0. Okay, so this is the point. Look at the scale on the graph, and each box is 100. So it's starting at 100, not at 0. And then it tells you that it's 600 after half an hour. So let's look at the scale at the bottom. 1, 2, 3, 4 boxes over is 1 hour. So 2 boxes over will be after half an hour. And it's saying that the temperature is 600 here. So we have 2 points we know. If we're saying the time is the x-axis and the temperature is the y-axis, at time 0 the temperature is 100. And at time 0.5 or 1/2 the temperature is 600. So the slope of that line is the second x minus the first x, 600 minus 100, over, second y minus the first y, this is playing the role of y, over the second x minus the first x. So I'm going to have 500 over 0.5, and that's 1,000. Then the units on slope are units of y, so degrees F, per units of x, hour. So the oven temperature is increasing at a rate of 1,000 degrees Fahrenheit per hour everywhere between time 0, and it's a straight line, so it keeps going up at that temperature until this point right here after 3/4 of an hour. Between time 0 and time 3/4 of an hour. So the rate of increase of a straight line is its slope. Well, derivative is rate of change is the slope. So when they're asking for T prime at 0.5, that's how fast is the temperature changing when the time is 0.5. Well, it's changing at the rate of the slope because it's a straight line. So it's 1,000 degrees F per hour. That's the rate of change of the temperature at the point where time is 0.5. Okay, then it says find and interpret T prime of 2. So now we're at time 2. We come look up here at what's happening on the graph. Well, once the oven gets hot, it stays hot for a couple of hours to cook everything off of the surfaces. So the temperature is not changing. If something's not changing, its rate of change is 0. It's changing 0 degrees per hour for all times between 3/4 and 3 hours. It's not changing. So then when we look at time 3.5, so here's time 3.5. So we're at this point. Well, again, it's a straight line. So again, we're going to look at slope. And we're going to say, oh, look, it does the mirror image of what it did heating up when it's cooling off. So it's going from 600. So here's the cooling off part. Time and temperature. So the temperature is 600 when the time is 3.25 hours. And the temperature is down to 100 at 3.75 hours. So now the slope is going to be the second y minus the first y over the second x minus the first x. So that's going to be negative 500 over 0.5 or negative 1,000 degrees per hour. So that's because the temperature is decreasing. So you get a negative number for the slope of the tangent line when the thing is decreasing. So this one's going to be negative 1,000 degrees F per hour. So let me know if you still have questions and I'll be happy to make more videos as you need them.